So far, all the classes we created can be instantiated, which means we can create instances from these classes. There's a category of classes that cannot be instantiated, which is called the abstract class. You cannot create object instance directly from the class, abstract class, but other classes can be derived from them. An abstract class serves as a superclass for other classes. It represents the generic or abstract form of all the classes that are derived from it. A class becomes abstract when you place the abstract keyword in the class definition. Usually, we have abstract methods inside an abstract class. Abstract method has no body and must be overridden in the subclass. An abstract method is a method that appears in the superclass but expects to be overwritten in the subclass. The definition like student. Student is an abstract class. It has abstract method like here, public abstract int get the remaining hours. There's no body of this method, only a semicolon right after the method header. But it does have some kind of constructor, some kind of real non-abstract method. And the computer scientist, computer science student derives from student, extends from student. So it can have its own constructor, its own method, and it must implement the get remaining hours, which is an override. The reason we use the abstract class and abstract method usually is to define a framework. For example, in your package, you want to use a certain kind of class. You want whoever implements your library will conform to your standard. So you define an abstract class, and with abstract method, if other people want to use your package, they must derive something from your code, from your framework, so that your whole package stays integrated. The keyword abstract appears in the method header, so that and that header ends with a semicolon. Any class that contains abstract class automatically becomes abstract. And because the abstract method must be does not contain any information, any subclass wants to inherit from the abstract class must override that abstract method with some real code. Otherwise, you will have a compiler error. Abstract methods are used to ensure a subclass implements the method. If all the methods are abstract in the abstract class, there's a special form that we use to define this abstract class, which is called interface. Interface is essentially an abstract class. The only difference is this interface, all methods are abstract. So because all methods are abstract, you cannot create a real instance. Otherwise, that instance will have no implementation of the method. And all the methods must be written elsewhere, which means it's an abstract method, right? The purpose of the interface is to specify behavior for other classes, just like what we said. You define a framework for the classes that you want other people to use. Usually because you have a library and you write your own program and you want people to extend your program in the framework that you define. It's often said that an interface is like a contract, and when a class implements an interface, it must adhere to the contract. An interface looks similar to a class except the keyword interface is used instead of the keyword class. And the methods are specified have no bodies. Only headers are terminated by semicolons. The general format is like this. public interface name with a bunch of method headers. All methods specified by interface are public by default because interface is just defining how your class should behave. It does not define how you implement this class. So there's no implementation detail, no data, no inside data, no encapsulation. All these are defined by whoever inherits this interface or implements this interface, not by the people who define the interface. A class can implement one or more interfaces. If a class implements an interface, it uses the implements keyword. Like this class final exam extends graded activity and also implements relative interface. Let's bring up relative. As you can see, there's an interface with only three field methods. All three methods are abstract methods with a header and a semicolon. And there's no implement detail on how you implement this equals or is greater or is less. Because basically whatever you want to do is just to define the future class should have these three methods. But you do not define how these are achieved. And for this final exam 3, it extends graded activity. It's by itself, it's a graded activity. It also implements this interface. So it should have all the methods and fields defined by graded activity, plus all the methods, all the interface defined by the interface. So for this final exam 3, it has a graded activity, set score, the get score, things like this. It also must define the equals, is greater and is less than, is less method provided by the interface. So by defining this relatable interface, you are forcing this final exam to implement these three methods. It must have these three methods. This can be useful when you want someone else to use your code, but you want them to use your code in a way that you expect them. An interface can contain field declarations, but all fields in the interface are treated final and static because there's no instance, right? There's no instance. You cannot create an instance for interface. So there's no such thing as instance field or instance method. Everything is static and everything is final. Because they automatically become final, you must provide the initialization value. You must define them like equals to 1, equals to 2. And in this interface, field 1 and field 2 are final static int. Any class implement this interface will access to these variables because they are by default public. So every class implement this interface will have access to these variables, as well as any outside class. They will be able to access these fields, these values. We talked about inheritance, like every class can inherit from some other class. This is called single inheritance. There's also the concept of multiple inheritance, that a class can inherit from multiple other classes. But Java does not support multi-inheritance. Java only supports single inheritance. If you want Java class to behave like several other classes, you need to define interface and define multiple implementation. Remember, there's no multiple extension or no multiple inheritance. If you want your class to behave like certain other classes combined, you need to use interface. You can do multiple implementation. When a class implements multiple interfaces, it must provide the method specified by all of them. To specify multiple interfaces in the class definition, you can list the name of the interfaces separated by commas after the implements keyword. So like this, final exam derives from graded activity and implements, note this dashed line, implements this relatable interface. Java also allows you to create reference variables of an interface in type. So you can define the instance as an interface, but when you create the instance, you still need to create from a subclass that implements the interface and can be instantiated. An interface reference variable can reference any object that implements that interface. When you run, this is for the compiler. At the runtime, you still need to use the class's implementation of that method. And this is another example of polymorphism. Like we have a retail item. Let me bring up Eclipse. Retail item is an interface which defines a get price method. And we have like DVD movies is a retail item. It implements retail item, and it has to implement that get retail price interface. Now in the retail item, I think polymorphism interface demo, you can create a compact disk CD. You can create a DVD movie, and both of them can use get retail price, because this retail price actually comes from the retail item instance. And this retail item instance is created by using this show price of a DVD movie, which is implementation of the interface. So the chain creates like here. You are creating a DVD movie class instance, which implements the interface. When you pass this as a parameter, because the receiving the receiving method defines the retail item interface, you are passing this object in as a retail item. And the retail item instance will have this get retail price method. This is another example of polymorphism. In the example code, two retail items can be created, and each referencing to a different object. But because you are passing in the interface retail item, an inheritance relationship known as interface inheritance is established, which we also call interface implementation. A reference to an interface can point to any class that implements that interface. That's when you pass the retail interface into the parameter list. But you cannot create an instance of an interface because interface does not have implementation details. You cannot do that interface definition. You cannot create an instance with all the definitions. When the interface variable references an object, only the method declared in the interface are available. That's why in this code, you have to define this as an interface object. You cannot define this as a DVD movie or a compact disc because they do not have this. Because you want to utilize the polymorphism and the enclosure of these two objects, of these two classes, is the interface retail item. And finally, the beginning in Java 8, interfaces may have a default method. A default method is an interface method that has a body. You can add new method to an existing interface without causing error in the classes, it already implements the interface. Like interface default method, let's show. Like this one, it actually have a default method, display. It's displayable. Let's see. This is the method, and this implements the display method.